when we started this project quite a few years ago, it was our need as a business to have a more productive tool, more productive than Java, because we realized that we have very many lines of code written in Java, and things all we are stuck with as programmers is Java for making our tools. So we were looking for a better language. We looked around. We didn't find anything that suited our needs. I'm not going into details now. And we figured that, yeah, it's time to make a language that will suit our needs, because our needs are very similar to other people's needs. So it's a modern language on the Java platform and on the JavaScript platform as it comes along. And the target audience is you, everybody. It's a general purpose language, so you can use it. Yeah, I can actually show you a slide on that. So we're, yeah. So the first thing is that you can compile Kotlin to Java bytecode and run on Android or on the server or on the desktop, of course. So, and actually today it's getting traction on Android, so people are making mobile applications with Kotlin a lot. Also, of course, there are web applications written in Kotlin. And we as a company use it more and more for our like web-based, browser-based projects. And the other track would be to compile to JavaScript, run on Node or in the browser. And also, if you connect the two at the bottom, you can run your Java code, Kotlin code on the JVM in the server, and your Kotlin JS code in the client, and the two can talk to each other, and it will be the same language. And the same strictly typed language, which many people would actually like. So, I'm sorry for messy introduction, because I was lost without my slides. I can't talk without slides, you know. So anyway, this is not intended to be a real introduction for the language. Please refer to the website. The only takeaway from here is that it's a good one, and it's open source, so you can actually dig into implementation and send us a patch if you like. So if you're curious about the particular language features, go ahead and check out the website. You can even play with the language in the browser. So we have like a small web-based IDE there. Just to name a few things, there is a list of 4 extension functions, builders, primary constructors, delegated properties, other words I'm not going to explain today. And we are proceeding to the first challenge. So I'm here to talk about things that are maybe a little bit out of the traditional focus of people who are thinking about languages. And the first thing is that whenever you think of an implementation of a programming language, most people think compilers, right? So to implement a language means to make a compiler. But as Gilad mentioned in the previous session, today's people want a little more, or rather a lot more than just a compiler. People need a whole tool chain, and a big part of it is the integrated environment. And there is a thing about compilers and integrated environments, because the compiler is like a very narrowly targeted tool. It's trained to do a single thing very well. It takes a bunch of code, and it spits out a bunch of whatever class files or something else. The IDE, on the other hand, is very different. It's something that can help you in very many ways, right? And it can help you navigate, analyze your code, find your, or restructure your code, refactor, so on and so forth. So, and when you build a compiler and the IDE alongside each other, it turns out that you definitely want to reuse a lot of code, because you have very complex logic in your compiler front end. Your compiler knows how to analyze code, but can you actually reuse this code in the IDE? This is a challenge, because if you think of what IDEs do, here are 3 crucial points that IDEs actually use and the compilers don't care about. So in the IDE, when you open a file, you have it highlighted, but not only like with your keywords and stuff, but also all the errors and everything, right? So, and whenever you see a name there, it says foo, right? You can control click on that name and get to the declaration for this name, right? So this is something compilers kind of do, but in a different manner. They don't care for like one identifier somewhere. They just do it for the whole project of millions of lines of code. So one thing IDE does is navigation, and then there is reverse navigation that's called find usages. When you have a declaration already and want to know where it's used in your project. And this is something compilers don't care about at all, or unless they do some specific optimizations. And then, of course, IDEs highlight files. So it takes a single file and analyzes it. Compilers don't do that. They only take the whole project most of the time. So I'll explain one thing of these three, how it works, which is find usages, to just give you a taste of how a compiler is different from the IDE. So find usages is like the most controversial of the three. So I have a symbol, that foo on the left. It may be whatever, a class, a function, doesn't matter. Something that can be referred to in your program. And I ask my IDE, please show me all the usages of this foo in the project. First of all, there can be other foos, right? So this can be an overloaded function. Other packages may have the class with the same short name, so on and so forth. So you cannot simply grep for all foos in the project and show the list, right? So what you actually need to do is recognize which foo names refer to the actual one. So one way of doing that is just analyze the whole project, take every foo there and check if it refers to the original declaration, right? But it has this, tricky point of analyzing the whole project. It's something you don't want to do because the whole project may be like millions of lines of code and you'll wait for a very long time while it's analyzing. So what an IDE does, at least IntelliJ IDEs do that, or JetBrains IDEs, it keeps a word index, which means that all the files are not entirely analyzed. They are just processed with a lexical analyzer. All the identifiers are recognized and stored in a kind of a database, in an index. So you, instead of like grepping literally through all the files, you pre-compute all that. You ask the word index, please tell me which files in the project have the name foo mentioned anywhere. Like it may be anywhere where it's code. Any name in the code. It can be a type, a function reference, anything. So give me the files that have foo. And then for every occurrence, it's not the whole file. It's just the place in the file, the particular name that is there. Resolve that name and check if it refers to the declaration I had. Right? So this is something compilers don't really do. Take a file and a single identifier in the middle of the file and do as little work as possible to resolve that name correctly. So this is something a compiler doesn't do ever. And now what I want to do is write a single piece of code in my type checker, for example, for it to work for the compiler, which takes the whole file or the whole project and compiles it, and for this case, where it needs to take one reference in the middle of the huge code base and resolve it. So it's a huge controversy about how you design the algorithms around your language. It's not even about the particular language design, it's about how you structure your implementation, your algorithms, to address both the challenge of the compilation and the challenge of the interactive responsive IDE. Questions here? Go ahead. Okay, so the word index is the database that lists which words are mentioned in which files. So it's updated every time any file is changed or a file is added to the project. So in the IDE, when you open a project for the first time, it will be indexing the whole thing for some time before it can do anything because it has to scan everything. But it's a quick analysis, so it does not analyze types or even resolve names, nothing there. More questions? Yep. Yeah. So the question is, why not just resolve everything once and then use the resolve database for that? The thing is that whenever you change any declaration in your program, that resolve database is invalidated. A lot of it. Well, actually, there are different approaches to this. Like, for example, in Eclipse, which runs on an incremental compiler, they kind of use this, a very particular version of this. So you can do this like a resolve cache and invalidate parts of it when your declarations change. And this is one way of doing this. It's a very complicated way. Another way, a lot simpler one, is to make your resolve so fast that you don't have to do that. More questions? Okay. Then, so this was a meta challenge, like a challenge about how you think about your language implementations or language algorithms. So the next one will be about language design already. And yeah, we'll be talking about nulls. Yeah. Kind of. I'll tell you about it. So, thing is that things may not be there, you know. And there is a big fuss about how you deal with things that are not there. And Java's take on this, for example, is that when you say that something is a string, it's not necessarily a string. Maybe a string or a null, right? And nevertheless, you can call a method on that something, and sometimes it breaks, obviously. This is the way to go. I'm not saying it's bad. It has its implications. So you probably know that null pointer exceptions are one of the most frequent errors in Java programs, which is not surprising. So in Kotlin, we're trying to tackle this and make something more type safe. So in Kotlin, when you say that something is a string, it has to be a string. So when you're trying to assign a null to something typed as a string, you're not allowed to do that. On the other hand, you can safely dereference this variable and be sure that it doesn't break. Now, when you want a null, an absent string, you have to designate that in the type. So this string question mark is a type, which is a string or null, nullable string. I would call that nullable types. So in Kotlin, the type system tracks your absent objects and lets you know that when you're trying to reference something which is nullable, you're not allowed to do that right away without a check, because it may break. So it gives you an error at compile time. Questions here? Should be pretty obvious. All right, now if you think about it, if something is nullable, you cannot dereference it, but then what use can you make of it, right? So the language has some devices for dealing with nulls in a convenient way. So the best device for that is the conditional operator. So when I have my nullable string, I can check that it is not null, and then I'm allowed to reference it safely. So the compiler knows that if you have checked that this is not null, the type of the variable is kind of different now, and we have something called smart casts. This is happening behind the scenes here. So the compiler knows that now this s.length is a safe checked call. So it will not complain. It's even clever enough to see that if you have broken your control flow somewhere, like if you check for null and return from the method, on the next line, this s is guaranteed not to be null. So it will be fine to reference it. So first thing, for very many complex safety features is have a smart compiler. So we have one. Then, of course, in many use cases, you want something not as heavy as an if. So there are some specific devices for managing nulls in the language. So the first one, which is question mark dot, is it's called a safe call operator, which means that if the left-hand side is a null, do nothing. The expression will evaluate to null if s is null, And if the left-hand side is okay, you just call the method and get the result. Then the next one is something interesting. It's a double exclamation mark operator, which, yeah, go ahead. Yeah, it will be a nullable integer. Yeah, integer or null. Yeah, the next thing is a double bang operator, which says if s is null, do what? Throw an exception. So this is kind of like Java, but explicitly. You say, I want an exception here if it is null. And when you're looking at the code and your stack trace, you get a clear designation of where this null pointer comes from. And the last one is called Elvis operator by the Groovy people who introduced this. So we just borrowed the syntax from them, and it basically gives a default value to a nullable. Okay, so we have a bunch of devices that play nicely with nulls. And the takeaway from this part of the talk is that Kotlin is good with nulls. Okay? So if you remember nothing else, remember this. Go ahead.
From a language design perspective, did you think about not introducing the double bang and not letting people do that?
Yes, we did. Does work. People need that. Yeah. Default, come again, please. Uh-huh. Oh, yeah. So if you say allocate an array of a fixed length that has to contain strings, you have to give the allocator a function that initializes every cell in the array. Okay, so Kotlin is good with nulls, isn't it? But now Kotlin is interoperable with Java, right? So the thing is that whenever you write a program in Kotlin for the JVM, you can use any Java library. And your Java code can call Kotlin, so it's interoperable both ways. And actually, it doesn't have to be a library. You can just write a Java file next to a Kotlin file and reference both ways. So Kotlin is good with nulls, but Java isn't, right? So whenever I'm calling a Java library, the Kotlin compiler has to think a little. Like, here's the Java declaration. The function returns a string. And now, what do you mean a string? Is it a nullable string or non-null string? And this same function takes a list of string. So is it a list of string, a list of nullable strings, a nullable list of strings, or a nullable list of nullable strings? So that's a question. And the Java class doesn't give you any information of that. So you have no idea. When a Kotlin compiler looks at the Java class, there is no way to know which one of those is meant. So like the type-safe language designer's intuition here will be to say, okay, we go the safest way. Anything can be null in Java, right? So we take a nullable string on the left and the nullable list of nullable strings on the right, because anything can be null. And yeah, this is the safest way. Let's try to work with it. This is actually where we started a few years ago. So yeah, whenever you use anything from Java now, the dot is not your way. Because this Java value can be null. The toString you call on that Java value can be null. And so there you are. You have to guard every dereference you have. This doesn't happen with Kotlin, because with Kotlin, you have your non-null types and everything is good and safe. But with Java, you have no information. So the best you can get is something like this, like safe call for every dot. And then to use a plus, there is no safe call for an infix operation, so you have to put a double bang there to add two numbers. I don't like that. But okay, but you can, one can argue that this may be a price you're willing to pay, just a second. This may be a price you're willing to pay for type safety. Like you're guaranteed not to have null pointer exceptions, and this may be the burden you might want to carry along. But there will be another thing after I answer the question. Go ahead.
I don't get why you need to define nullable types, because if you define the type on the nullable type and using that question mark operator, you could have nullables propagate everywhere. Doesn't that mean that you should only have nullable types for everything and not the real types?
Well, we could only have nullable types for everything But then, what would be the point of what would be the type of double bang operator, for example? Like, if we just replace all the dots in the program by question mark dots, it doesn't change anything. Just the program sometimes doesn't run because something was null somewhere, right? And also, when you very often you require a value somewhere. Some algorithm cannot work without a value. So the only way will be to have the question mark dot semantics that if you don't have a value, the algorithm doesn't run. So instead of a null pointer exception, you'd have like a stalled program somewhere because it can't progress. Okay, yeah, so coming back. So this line is not so bad. It's bad, but it's not so bad. You may be willing to pay this price for type safety. But then there's another problem, like the list. I want a list of string in Kotlin, and I want to get it from Java. So what Java returns me, remember, is a nullable list of nullable strings, right? So, okay, I can get rid of the outermost null with the double bang operator, and it will be a list of nullable strings. But a list of nullable strings is not a list of string. You cannot assign a list of nullable strings to a list of string here. So you're stuck. There is no way, no nice operator in Kotlin, and no nice operator I can think about that could mitigate this problem. So the thing is that this question mark here is stuck forever. And if there is even no way to properly fail at runtime if the actual list contains a null because you don't know how to inspect it. Go ahead. Yeah, you could. And this is inherently very slow, right? At least. And also, a list is a very nice structure. It's a sequence of elements. But some foo generic class can be anything. Like, I might not even know as a human how to inspect whether it contains nullable string as an argument or not. So, the takeaway from here is that the safest option doesn't work. You just get stuck there. That's it. So for quite some time, we tried to fight this with annotations. So we tried to annotate Java code with not null here and there to get some type safety into the Java language. So basically, those annotations help you rule out some of the cases. But again, Java before 8, I think Android, doesn't have type annotations. So I cannot annotate the string inside the list. And annotations are cumbersome to work with. And sometimes you don't have control over your code, so you have a binary library, and you need to attach the annotation somewhere from the outside, and then it gets lots of configuration issues, so on and so forth. So the annotation way is difficult and doesn't really help. So we actually struggled with this for quite some time. We tried to make this approach work because it seems pretty, type safe, and we wanted this. But then we had to face it. So among the 3 options here, null safety, convenience, and Java interoperability, apparently you have to pick 2. Sorry. So since we cannot double-cross Java interop, and there is no point in double-crossing convenience, just a second, we're double-crossing the safety part. Go ahead.
So, I'm an academic.
Yes.
So I expect people to use relevant theory. And you've given a very nice development, but you've never mentioned the relevant theory here. And in particular, you haven't mentioned an option of the relevant theory that I think works for you,
Yep.
which is that when you move between the languages, you do some additional checking with something like a contract in bracket, or something like the plane calculus, which is the theory that I developed. So doesn't that solve your problem?
Well, disclaimer. I'm not very familiar with the developments you're talking about, but
You should be.
yes. Yes, but just a step back. So the non-null annotations I mentioned before are the contracts, somehow. These are the contracts on the methods. And what we tried was, for example, to infer them automatically, inspecting the bytecode and trying to infer those contracts automatically. So the thing there is that you can do that. It's not very fast. So if you try to automate these things, these are offline algorithms. You don't do that in the compiler without carrying huge artifacts along with your libraries, and users may not want or have the skill or the time to analyze their libraries they're using. So it's not smooth interop. So if I have to manually or automatically annotate a huge amount of code to interop with it nicely, and the other option is terrible, this is not a practical way to go.
But so the way I would do it, right, is at the interface.
Okay?
On the Kotlin side, I would say, okay, Java thinks this is string to listed string to string. But I've got 4 choices here, and you give the choice that you want, and then you automatically generate some mediating code. Okay, and the mediating code might give you some runtime expense. I would agree that that might be something you can avoid. But now you've got the choice. Do I want ease for the user or runtime expense?
Okay, so
Choose how you're going to do it. But what I would say, focus on the interface. Focus on what you want at the interface that you don't need to change the existing code. Of course, that's very expensive.
yeah, so the thing is,
Focus here you can apply.
yeah, so this inherently complicates the interface. So the experience we would like to deliver is that you plug in a Java library and it works. So on top of the approach I'll be presenting in a second, you can do what you're talking about, and this is something we're working with at the moment, but we want it by default to require zero thinking on the user side. So when you switch from Java to Kotlin, I want it to be transparent and require no interaction on the interface. So an interface must be as transparent as possible. So if I have to specify something there, it's a lot of work because the library I'm using can be huge and the user doesn't know what's the particular semantics in the library. So they don't have even the qualification to properly annotate on the interface, like properly specify things on the interface. So this, we can take the rest of it offline. I'm sorry, I don't have enough time to.
Okay, no,
Yeah.
but that was extremely helpful, right? Because you said, okay, the additional constraint is we want no extra work at the interface
Exactly,
at
yeah.
all. And the
Yeah.
way to put it is we want it to be as simple as possible.
Yeah.
And the way I would characterize it is actually you're trying to make it simpler than is possible. The best thing for your user would be to force them to think about it at the interface because you have to. There really is something to think about there. But we can talk about that.
Yeah,
offline.
sure.
That's fine.
Yeah, thank you. So this is where academia comes in actually, because with the help of a professor from Cornell, Ross State, we developed something very close in the spirit to gradial typing, which we call platform types in Kotlin. And I'll give you a little taste of what it is like without any calculus, because Phil will catch me on every error I make there. So the idea behind platform types is that you have to admit that you don't know whether it's nullable or not in Java. So when we see a string in Java, we say, okay, it's a platform string. We have no idea whether it's nullable or not. So the notation is the exclamation mark at the end, and you cannot use that in the language, actually. So whenever we see the generic type, it's a platform bar of platform strings. I'm not using collections here because collections are complicated. I'm probably not going to have time to present you the thing about collections, but just a short note, the collections in Kotlin are divided into read-only interfaces and mutable ones, and they are not divided so in Java. So we are doing lots of compiler magic there, and whenever we see a collection in Java, it's actually a platform collection, which says, I don't know whether it's mutable or not, and I don't know whether it's nullable or not. So here I gave up on my list and used bar because bar is fine. It's simple and collection is not. So yeah, so the representation is like confess to the user and to yourself that this is a platform type. You don't know whether it's nullable or not. So on the user side, it means that whenever you have a proper string, you can dereference it and you get a warning whenever you're trying to treat it as a null. So if you make a safe call, it's a warning. With a nullable string, you cannot dereference, and safe call and double exclamation mark are legitimate constructs. For the platform string, you can dereference. It's risky. It may break. But it's what you expect from Java, right? Java breaks on dereferencing objects. It's OK. So, and the nullable devices are also applicable here. So pretty straightforward, isn't it? Now, assignability rules. Normal Kotlin allows you to assign a string to a nullable string, but not vice versa, right? Because this may contain a null which is not in that type. Now, with a platform string, it is assignable from both of those, which obviously may break when you try to assign a platform string which is actually null to a string which is not supposed to be null. So there is a runtime check emitted that will break if you mess things up. And unfortunately, this makes assignability relation in the language non-transitive. So there is a way around this arrow, which can lead to an error, a runtime error, which makes this a non-transitive relation, because you cannot assign a nullable string to a string directly, but you can do it through Java, which is the way the world works, actually. Go ahead.
So do you get the null pointer exception at the point of the assignment?
Yes, you get a null pointer exception at the point of the assignment. So this is, yeah?
That you remove a list of the strings, in fact the whole list?
No, no. When you have a list of strings and you assign it to, yeah, thank you. This only works, of course, on the simple, sorry? Yeah. The null pointers only work on the values themselves, so the contents of the list will not be checked and will break where Java generics break on any type unsafe operation. So at the point of getting an element from a list and putting it into a non-null variable. So this is very much how erased generics work. Okay, so a few notes on this. First of all, platform types are not denotable in the language. You cannot declare something to be a platform string. So the string exclamation mark is just notation, not the syntax in the language, which means that pure Kotlin is null safe, as safe as it was when we were trying to impose null safety upon Java. So we deliberately decided to lose null safety when it comes to Java interop, but we want to save it for the pure Kotlin code. Then Kotlin plus Java, this is just an observation. When you interact with Java, you're as safe as Java, sorry. If you're interacting with the untrusted entity, you're as trustworthy as the entity, right? So we're as safe as Java there. Annotations still work, and this is a part of the conversation we're having earlier. So you can still specify contracts, even more complicated contracts than just non-null. And this will turn the platform types into proper Kotlin types and give you some extra type safety, but this is voluntarily. So you can, basically you can plug the annotations out of the system, and all the code that used to compile with annotations will compile without them. And this is the deliberate design goal. And yeah, also when you think JavaScript is even more unsafe than Java, because when you're talking about like types in JavaScript, it's like, what are you talking about? What kind of types are there in the JavaScript code? There are types at the runtime, but no types in the code. So basically, for JavaScript, there is one platform type called dynamic, and and you can do anything with it. So the machinery, the calculus, and the semantics behind it are the same as for platform types. Basically, a platform type is a range from, say, string to a nullable string, and dynamic is a range from nothing to anything. So this is how you reuse these things. Yeah. Oh, this is a very big question, which I cannot actually answer off the top of my head. So the answer is it's complicated. And most of the time I think it's undefined, but I'm not sure. So, to summarize, we had to pay quite a bit. We added extra complexity to the type system. So the whole platform types machinery is an involved part of the compiler. We had to sacrifice, so we did that to actually make our language less safe on the boundary when Java comes in. But as a benefit, we got smooth interop. So when people start using Kotlin with Java libraries, they don't know about platform types. And they don't notice them until they need it. And of course, you usually need these things when something breaks. But it seems to be the right trade-off here, because it's easy for the users, and 90% of the cases it's very intuitive to use. Sometimes it's complicated, but it's inherently complicated there. Any questions at this point? Yeah, go ahead.
So if you are very careful at the interface between Java and Kotlin,
Yeah.
can you kind of convert your Java values or objects into safe Kotlin types? Because like basically, like it would be a pity if you say you have 90% Kotlin code and 10% Java, and then still the safety you get is the Java. Like you want to have a way to.
Oh, I see. Yeah. So basically, in Kotlin, you have pretty clear boundaries between the interop and the pure Kotlin code, because at the method boundary, you have to declare types, and platform types are not denotable. So, so this is almost true. So the parameter types have to be written down actually, and the return type can be inferred from Java. So the platform type can go into there. But basically, if you specify all your types at the boundary, you have to deal with the platform nature somehow. Otherwise, it will break when you access this. So, so the answer is, with simple values, totally yes. With collections, you can have discipline to do that. With other generic types, you have to devise your own discipline for every type. Because if you have a foo of t in Java, you not necessarily have a way of checking if the t inside is nullable or not, and even breaking at the right time. So you have to devise your own way of making sure. And this is something I don't know how to explain easily to the compiler.
I guess what I'm saying is basically like, is there a way to find out to like make sure that there are no platform types accidentally?
Yeah, there is a way to make sure that there are no platform types behind some boundary. That's right. But with generics, you can get even proper Kotlin types break because the proper check wasn't made behind the boundary. Yeah, so this is something that happens very often. So when you define something in Kotlin, it's a proper Kotlin class. So it used to have all the null safety information. When you give it to Java and get it back, it doesn't have those platform types all over all of its methods, right? So if it had a method that was returning, say, string, it still returns string, right? But the value itself is not known to be null or not null. The same thing with the generic argument. So if I make a mutable list of strings in Kotlin, give it to Java, Java could have put a null into that list. So I cannot guard for that.
So if you're interacting with something not very typed like Java, or even less typed like JavaScript, as compared to Kotlin, one might want to sit down and by hand write out something that says, okay, that thing over there is a Java list of JavaScript, all of which might be nullable, but over here I've got a Kotlin list of Kotlin string, none of which are nullable. You just write a little interface class that does the appropriate checks as you go across the boundary. Presumably you can do that?
Yeah, sure.
Why don't you just let somebody declare the type, and then you would write the interface code for them from the type?
Let me see. So first of all, for a generic class coming from Java, I cannot generate the code because I don't know how I have a box of t in Java. How do I write the code that makes sure that the t is not null there? I don't know the semantics of the box. So for a list, I do. For a box, I don't. So this is one thing. And then, again, so this is something we can do sometimes, and that's what we are doing with the annotations. When we are either inferring them from the Java side, not to burden the user with declaring anything, or can ask the user to declare something and it will be automatic. But this works only for simple values, where I know how to check if it is null or not and break, because otherwise I can get an unsafe null from there. And
In Java, we know how to check if something is null.
yeah, if something particular, but not, so I may, I see, okay. So when I have a box of t, I could wrap it at runtime and an object that checks all the results of all the methods and breaks appropriately. This is a way to go, theoretically. There are caveats to this, because first of all, it breaks equality. When you wrap something on the JVM, you get a different identity for the object, and if somebody uses identity equals, it's broken. One thing, and then it's potentially a lot of wrapping, a lot of memory. So we're not willing to sacrifice this. Yeah, I'm sorry, I just have this. As many objects as you transfer between Java and Kotlin. So it can be a lot if you interact a lot.
What percent of the cost is it on a typical application?
It can be, well, I can easily imagine an application, 50% of memory traffic of which would be this wrapping, easily. It's like, so in Java we have this boxing of primitives. No. Oh, all right, yeah. Yeah, sure. So, thank you very much for your attention here. And if you have any questions, even if you're not Phil, just approach me in the corridor and I'll be happy to talk to you. Thank you very much.